Now, today we are going to start with the lasers, Einstein's coefficients and their relationship. Now, consider two energy levels E1 and E2 of atomic system such that E2 is greater than E1. Let the population of E1 and E2 be N1 and N2 respectively. Let the radiations of energy U nu, energy per unit volume of frequency range with frequency nu, be instant on an atomic system. That means, consider an energy level E1 and E2 system in which E1 is a ground state and E2 is a higher energy state, in which N1 is the number of atoms in the E1 energy state and N2 is the number of atoms in the E2 energy state. Let the radiations of energy density U nu with frequency nu be instant on an atomic system. What happens first is induced absorption occurs. As said in the previous sessions, we know what is induced absorption. That means an atom in the energy level E1 absorbs the energy and takes the transition to the energy level E2. That means the rate of absorption depends on the number of atoms in the lower energy state and the energy density U nu of the incident radiation. That means the rate of induced absorption, the more absorptions can take place if more the number of atoms in the E1 energy state and if more incident energy is being given. That means absorption is directly proportional to N1 and U nu, because more N1 leads to more absorption and more instant energy density incident, you will have more number of atoms going into the excited state. Therefore, rate of absorption is proportional to N1 U nu. Removing the constant of proportionality, we make it as B12 N1 U nu. Now, B12 is called as Einstein's coefficient of induced absorption. Why it is called as B12? Because the transitions are from one state, E1 state to E2 state, and it is requiring some additional energy which has to go to the transition. That means from 1 to 2 is being done by the external energy density U nu. So it is taken as B12 as Einstein's coefficient of induced absorption. Next, after reaching to energy state E2 atoms, there will be two types of emissions. One is spontaneous emission. That means an atom in the higher energy level E2 undergoes a transition to the energy level E1 voluntarily by emitting a photon. That means it doesn't require any external source to make the atom to come down to the ground state, that is E1 state. It comes spontaneously without any external aid, because it is in an excited state where the atom can stay for a very less period of time. Now, rate of spontaneous emission depends only on the number of atoms N2 in the energy state E2. Rate of spontaneous emission is directly proportional to N2, which indicates more the spontaneous emission will take place if more the atoms in the energy state E2. That means N2. More N2 means more spontaneous emissions can happen. Therefore, rate of spontaneous emissions is equal to A21 N2. It is called as A21 is called as Einstein's coefficient of spontaneous emission. That means here it is a transition from 2 to 1 without any external agency help. Therefore, it is said to be A21 is called as Einstein's coefficient of spontaneous emission. Another type of emission from E2 to E1 is nothing but a stimulated emission. Here, the rate of stimulated emission is proportional to the number of atoms N2 in the energy level E2 and the instant energy density U nu. Here, it is stimulated emission means emissions are happening by the external agency, that means incident energy density U nu. More atoms will be coming down if the more energy density is being incident on such a system. That means stimulated emission is proportional to N2 and U2, because stimulated emissions will be more if the number of atoms in the E2 state are more, and also if incident energy density is more, then more number of atoms can come from E2 state to E1 state. Therefore, rate of stimulated emission is proportional to N2 and U nu. Here, removing the constant of proportionality, we take it as B21 and N2 into U nu. B21 is called as Einstein's coefficient of stimulated emission. So we can rate it as rate of stimulated emission is equal to B21 N2 u nu. B21 is called as Einstein's coefficient of stimulated emission, where the transitions are happening from energy state 2 to 1 with the help of external incident energy density u nu. Now at thermal equilibrium, rate of absorption is equal to rate of spontaneous emission plus rate of stimulated emission. What is absorption? Absorption is nothing but moving the atoms from E1 to E2. And emission takes place when it is moving from E2 to E1. Since ground state is the most stable state, the rate of absorption is equal to sum of the rate of spontaneous emission and the rate of stimulated emission. That means whatever the atoms goes from from E1 to E2, it has to come back to E1 state either by spontaneous emission or by stimulated emission. So from the equation, rate of absorption, if you look at the previous slide, rate of absorption is B12N1 u nu is equal to A21N2 plus B21N2 u nu. This is the equation which we have framed in this slide. We have written that rate of absorption is the sum of rate of spontaneous emission and the stimulated emission. Rearranging the terms and bringing the u nu to one side and rearranging the terms, you are getting the equation 1 as u nu is equal to A21 by B21 is equal to 1 by B12 by B21 into N1 by N2 minus 1, which is called as equation 1. Now from Boltzmann's law of thermal equilibrium of an atomic system, we have N2 by N1 is equal to e to the power of minus E2 minus E1 by kT, where K is Boltzmann constant and T is the temperature. But we know that E2 minus E1 is nothing but h nu. Substituting the value of E2 minus E1 is equal to h nu into this, N2 by N1 is equal to e to the power of minus h nu by kT. Now taking the reciprocal, N1 by N2 is equal to e to the power of h nu by kT. Now substituting the value of N1 by N2 is equal to e to the power of h nu by kT in the equation 1, we get u nu is equal to A21 by B21 into 1 by B12 by B21 e to the power of h nu by kT minus 1. This is equation number 2. From Planck's law of energy density, the energy density is given by u nu is equal to 8 pi h nu cube by c cube into 1 by e to the power of h nu by kT minus 1. If you compare equation 2 and 3, comparing the equations 2 and 3, we can find out that A21 by B21 is equal to 8 pi h nu cube by c cube and B12 by B21 is equal to 1. Now I'll explain how these two has been compared. If you look at equation 2 and 3, see here left hand side u nu remains the same. Coming to the common value A21 by B21 and comparing the equation 3 before the bracket, 8 pi h nu cube by c cube is taken as A21 by B21. Now looking into the term inside the bracket and the coefficient of e to the power of h nu by kT, if you compare the coefficient of e to the power of h nu by kT from 2 and 3, we can make that B12 by B21 is equal to 1. This is how we have compared both the equations and we got the relation between the Einstein's coefficients. Now looking at these two equations, we can say that B12 by B21 is equal to 1 implies B12 is equal to B21. What is B12? It is a rate of induced absorption. Einstein's coefficient of induced absorption is equal to Einstein's coefficient of stimulated emission. Thus the coefficient of induced absorption is equal to coefficient of stimulated emission. Now in general we can write it as u nu is equal to A21 by B21 into 1 by e to the power of h nu by kT minus 1. This is the expression for the energy density in terms of Einstein's coefficients or the relation between the Einstein's coefficients. Here we have defined A21 is called as Einstein's coefficient of spontaneous emission. B21 is the Einstein's coefficient of stimulated emission and B12 is nothing but Einstein's coefficient of induced absorption. Now this is the relationship, this equation, final equation u nu is equal to A21 by B21 into 1 by e to the power of h nu by kT minus 1. This gives the relation expression of the energy density. It is a u nu, left hand side is nothing but energy density in terms of Einstein's coefficients or the relation between the Einstein's coefficients. Hope you understand. Thank you.